In continuation of our discussion on memory development in childhood, let's take a look at the transition from implicit memory to explicit memory. I am Nero, and welcome to the Cognitive Nomad. Memory development in infancy and toddlerhood undergoes a profound transition from implicit non-conscious memory processes to explicit conscious recollection. This transition reflects an underlying shift from rudimentary forms of consciousness, such as anoetic awareness, to more advanced noetic and autonoetic consciousness. This evolution of memory in early childhood is closely linked to cognitive maturation, particularly the development of self and autobiographical memory. Early theorists suggest that infants possess an inherent ability for long-term memory, while others contend that memory capacity in early infancy is limited and improves with cognitive maturation. Researchers have identified two distinct memory systems, the implicit memory system and the explicit memory system, which develop hierarchically during infancy. The ability to detect and react to environmental stimuli is foundational for early learning and survival. Implicit memory allows infants to form expectations about their surroundings, guiding behaviors such as attachment formation and preference learning. Studies on habituation and novelty preference indicate that infants as young as a few weeks old can recognize familiar stimuli and exhibit differential responses to new versus previously encountered stimuli. Such findings provide compelling evidence that early reactions to stimuli involve memory processes, even if they do not meet the criteria for explicit recall. Implicit memory, also known as procedural memory, operates without conscious awareness and is evident from birth. Infants rely on implicit memory to encode and to retrieve sensory and affective experiences, which are crucial for learning about the environment. This form of memory supports the retention of procedural tasks such as sucking reflexes and recognition of familiar voices. We have talked about studies on infant memory that have employed paradigms like the mobile conjugate reinforcement task, in which infants learn to associate their leg movement with the movement of a mobile. Findings indicate that 2-month-old exhibit memory retention for about 1 to 2 days, while 3 months can retain information for about 5 to 6 days, and 6-month-olds for approximately 14 days. This suggests that implicit memory improves with age. The deferred imitation task, another paradigm, further supports the presence of implicit memory in preverbal infants, as they can imitate observed actions after delays of up to 24 hours. Anoetic consciousness, characterized by lack of explicit awareness of memory, dominates early infancy and is present throughout the adult years. Infants experience the world as a continuous flow of sensation without explicit recollection of specific past events. Their interaction with caregivers contribute to the development of primary emotions and sensory associations, which form the foundation for later cognitive and social learning. These early experiences, while not explicitly remembered, can influence later behaviors and preferences, reinforcing the idea that early reactions to stimuli may indeed be classified as implicit memories. We can also term these early experiences that are not explicitly remembered as personal scripts. Personal scripts are complex affect-laden representations that individuals form to navigate personally significant experiences. These scripts, which guide behavior in different contexts, develop before children achieve autonoetic consciousness of events. Implicit memory plays a crucial role in forming these scripts, as children encode experiential information on procedural level, even when they cannot explicitly retrieve personal events. Shank and Abelson propose that infants of 4 months do have these personal scripts which act as standardized generalized episodes. These learned patterns of behavior become triggered by familiar contexts, enabling specific responses to occur. For example, an infant implicitly understands how to get their mother's attention differently than their father's, and this knowledge varies depending on the situational context, such as when the mother is cooking or after dinner. This procedural encoding occurs at an implicit level, reflecting anoetic consciousness rather than explicit episodic recollection. Implicit memory supports the development of personal scripts by allowing infants to encode and retrieve procedural and experiential knowledge without conscious awareness. These scripts, gradually formed through unconscious socializations, influence interaction with others and behavior from an early age. Now, to an important question, would we define early reactions to environmental stimuli as implicit memories? Early reactions to stimuli such as newborns recognizing their mother's voice or displaying startle responses to loud sounds suggest a form of memory-based learning. However, the classification of these reactions as implicit memories depends on how memory is conceptualized in infancy. A key distinction in defining early reactions to environmental stimuli as implicit memories lie in differentiating reflexive responses from learned memory-based behavior. Reflexes such as the motor reflex or the routine reflex occur without prior experience and diminish with neurological maturation. These responses are mediated by the brainstem and spinal cord rather than memory-related structures such as the hippocampus or basal ganglia. Conversely, conditioned responses such as those observed in classical and operant conditioning paradigms suggest a form of implicit learning. For example, a newborn can learn to associate a specific tone with a gentle air puff to the eye, demonstrating retention of learned associations. Similarly, infants exposed to repeated maternal speech patterns in the womb exhibit preferences for their mother's voices even after birth, indicating that prenatal experiences can shape postnatal behavior through implicit memory processes. Now, on the other hand, explicit memory or declarative memory involves the conscious recall of facts and experiences. It is further divided into episodic memory, which is memory for specific events, and semantic memory, which is memory for general knowledge or facts about the world. The transition to explicit memory coincides with the emergence of noetic consciousness, which enables children to recognize and recall factual information without reliving specific past experiences. During this period, children show improvements in object permanence, symbolic representation, and language acquisition, all of which contribute to the ability to store and retrieve knowledge in a context-independent manner. Studies using the novel event paradigm have shown that by 9 to 12 months, infants begin to exhibit explicit recall, demonstrated by their ability to sequence multi-step actions in the correct temporal order after delays of several weeks. A study by Simcock and Hain examined toddlers' ability to recall an event after a delay of 6 months to 1 year. While children could recognize event-related objects, the ability to verbally describe these events was constrained by their linguistic development, suggesting that early explicit memory may be encoded in a format that is inaccessible without sufficient language skills. The deferred imitation task provide additional evidence for explicit memory in infants. While Piaget originally suggested that the deferred imitation emerges between 18 to 24 months, Meltsov demonstrated that 9-month-old could imitate actions even after 24-hour delay. Furthermore, 14-month-olds have been shown to exhibit deferred imitation after a 4-month delay, suggesting an increasing capacity for explicit memory with age. The emergence of semantic memory coincides with advancements in social cognition. By around 14 months, infants begin to understand that others have intentions and goals, a milestone in the development of theory of mind. Language acquisition further enhances the child's ability to categorize and label experiences, strengthening their semantic memory network. By the age of 3 to 5 years, it is assumed that children develop autonoetic consciousness, which is fundamental to episodic memory. It enables individuals to mentally travel in time and re-experience past events. This shift is supported by the maturation of the prefrontal cortex and the hippocampal system, which facilitate the organization and retrieval of temporally bound memories. The development of autobiographical memory is closely tied to the emergence of self-concept. Studies suggest that self-recognition during the mirror task, which typically occurs from around 18 months to 24 months, marks an important transition in memory development. As children become more self-aware, they begin to construct a coherent narrative of their personal experiences, integrating episodic memories with their evolving sense of identity. We have established that implicit memories do emerge at birth, but are they a prerequisite for the storage and recall of future semantic memories? The presence of implicit memory from birth is evidenced by studies on habituation, classical conditioning, and deferred imitation, which indicate that infants as young as a few days old can form and retain learned associations. These early non-conscious memory processes provide a foundation for procedural learning and adaptive behaviors, ensuring that infants can interact effectively with their environment. As toddlers grow, implicit memory contributes to the formation of semantic memory, which encompasses factual knowledge and general information. Through repeated exposure to words and concepts, toddlers begin to form schemas, which are mental frameworks that help them to organize knowledge. These schemas are essential for efficient storage and retrieval of information as they transition into formal learning. As children continue to engage with the environment, the refinement of these schemas allow for more complex understanding and integration of new information, paving the way for advanced learning strategies in later educational settings. This process not only enhances their cognitive abilities, but also fosters a deeper connection between prior knowledge and new experiences. In this developmental stage at the toddler years, the medial prefrontal cortex and the hippocampus become increasingly involved in schema formation. As toddlers encounter new experiences, these brain regions help to integrate commonalities across events, allowing for the development of more complex memory structures that support later learning. This process enhances their ability to recall information and foster critical thinking skills, enabling them to make connections between different concepts and apply their knowledge in various contexts. This foundational cognitive development lays the groundwork for advanced learning strategies as children begin to categorize and relate information more effectively, ultimately preparing them for academic challenges ahead. As children progress through these early stages, the interplay between their expanding cognitive abilities and environmental interactions become crucial, shaping their understanding of the world around them. This dynamic relationship encourages exploration and inquiry, prompting children to ask questions and seek answers that deepen their comprehension and engagement with new ideas. Now, how do implicit memories affect the future recall of semantic memories? As children enter formal learning, implicit memories continue to influence their ability to recall and utilize semantic knowledge. The schemas developed during toddlerhood serve as scaffolds for imagining future events and scenarios, which is critical for problem solving and planning in school environment. These cognitive frameworks enable children to draw on past experiences, facilitating the understanding of new concepts and enhancing their overall learning outcomes. This dynamic relationship between early implicit memories and later or future semantic recollections underscores the importance of early experiences in shaping a child's cognitive development, ultimately influencing their ability to adapt and thrive in various social contexts. Another important role of early implicit memories in the formation of semantic memory is evidenced in language acquisition. Infants first acquire phonetic patterns and grammatical structures through implicit learning mechanisms before they can consciously recall words and meaning. Similarly, motor skills and problem-solving abilities develop through procedural memory systems before becoming accessible through explicit recall. Thus, while implicit memory functions independently of explicit recall, it does serve as a crucial precursor to the development of semantic and episodic memory. The development of memory in infancy and toddlerhood represents a dynamic progression from implicit to explicit memory. While implicit memory functions from birth, allowing infants to process and respond to environmental stimuli, explicit memory emerges gradually as cognitive and neural systems mature. The distinction between reflexive responses and learned implicit memories is crucial in understanding early memory processes. The research suggests that even in infancy, Experiences shape later behavior through memory-based mechanisms, supporting the argument that early reactions to stimuli can indeed be classified as implicit memories. The transition from implicit to explicit memory is influenced by multiple factors including neuromaturation, language acquisition, and social interactions. The development of noetic and autonoetic consciousness further refines memory processes, enabling the recall of specific past events and the formation of autobiographical memory. Understanding these developmental processes not only enhance our knowledge of cognitive growth, but also provides insight into early learning and the mechanisms underlying childhood amnesia. Further research may continue to explore how early experiences shape long-term cognitive functions and the role of implicit memory in the foundational stages of human development.